Hi there, my name is Antran. Today I'm going to help you guys figure out the coefficient between the basketball and the surface of the ground. I don't know if you can see that, but hopefully you'll see that sooner or later. So first, before we go to any specific detail, I'm going to find the height of the ball originally when it's at rest, and the height after the ball rebounds or hit the ground. In order to measure the height of the ball before I release the ball at rest, I'm going to use this ruler, and there. I'm going to set it at I'm going to set it at 180 I'm going to set it at 180. Nope, that's 180 is too high. So let me see. I'm going to set it at 150 pounds. 150 meters, not pounds. My bad. Alright, so there. Is 150 meters. I don't know if you can see that. Is the top number, the number 58. The number 58 is the feet, and 59 is also the feet. But the number 150 there, 150 is 150 is the meters, so the height is 150 meters. There. I'm sorry for if you cannot see it. Well, because the 150, the line, it touches the bar right here, so it's kind of hard to see. But yes, I'll set it at 150 meters. Or it equals to 59 feet, approximately 59 feet. So now I'm going to pick up the ball. This is a basketball, so it's very good for bouncing and doing these experiments. That's why I chose it. And I'm sorry for not showing my hand on the camera because it's way higher than the camera. There, I can bend it. Okay, so I just let the ruler touch the ground, and the ball right here is gonna go up and touch my hand. Okay, and like that. And then the ball right now is at rest, and I'll try to figure out the height once it rebounds. Ready? 1, 2, 3. So it was at 2 feet when it rebounds. Let's do it again. It's fun. So 2 feet, which is approximately 61 meters. Bounded at 2 feet, which was about 61 meters. Now let's play this game again. Okay, now I just set it like that, and again set it at 150 meters, which is 59 feet. Oh no, it's raining. Okay, so let's play this game quickly, and I gotta go home. And ready? Uh-oh. 1, 2, 1, 2, 3, go. Yep, it's about 2 feet. Okay, and because it's raining right now, so I'll probably have to go home, and then I'll come back and record the video again, and see you next time. And when I come back, I'll start at another height. Okay, thank you. Hi there, I'm back, and I truly apologize for not being able to make third experiments because it was really rainy outside, as you saw in the when I was outside, and the pool was kind of shaking. So now I'm going to show you how to find out the coefficient with the data we got. So in order to do that, we need to know the equation, which is v, the speed after collision divided by the speed before the collision. Okay, but by the way, we are I am going to find the mass. One more data, and then we can go straight to the calculation. So in order to find the mass, I need this thing. It's not an iPad or a tablet, it is a digital scale. So I turn it on, and it's now on. And also I'm going to get the ball. This is my basketball. I'm going to put it up, and it's 85 or 85. See, 85 grams. 85 grams there. Okay, and there. That's how you find the weight of it. And now I'm going to put the balance away. So the first step I'm going to do is to find out, well, because I already did all the calculation before this video, I'm just going to show you again so that we can save some time. Okay, so this is my work right there. Okay, and maybe if I show you this part right here, you won't be able to understand anything because it's almost to the end. So let's go to the beginning. First of all, we need the equations. We need the equations for, it's called the principle of conservation of impulse and energy, which is kinetic energy plus potential energy equal to, this before the collision equal to kinetic energy plus potential energy after a collision. So basically is the sum of energy before equal to the sum of energy after, as well as not only energy but the impulse. And this is the equation for kinetic energy, 1/2 mass VB1 plus and this is the equation for potential energy, mass times gravity times height. And this is gravity, and since we're living on planet Earth, we are going to use 9.81 meters per second squared, not any like 100 meter per second or etc. Okay, secondly, I'm going to show you what's given here. these are values given that I found during the experiments. The original position when I'm holding the ball, the final position when I drop the ball and it rebounds to maximum height is 0. Oh, my bad. This is this before. There are two events happened before and after collision. So this is before collision, when the ball is still in my hand, and this is when the ball reaches the ground, and this is the mass and the velocity when I'm still holding the ball. And so I just plug into the equation of principle of conservation of energy, which was that, you see, is exactly the same. So when you plug it in, you see that we don't have the final velocity, and so we need to find it, and after it I just calculate it and I got that. And so now I go next into the after the impact, after the collision. More specifically, impact and collision are the same. So again, I use the same equation. This is kinetic, potential, kinetic, and potential, and I just need to add both of them and make sure that both of them must be equal. And then again, I just write down what's given. I got those right there, what's given there, okay, and I just plug it into equation. I'm sorry, the camera sometimes blurry, but yes, there. That's the equation, and eventually you see the initial velocity when it just almost rebounds, like when this is the ground, the table right here is the ground when the ball reaches and it's gonna rebound. So when it's almost rebounds right there is that number, okay. So why do we need to find velocity? Well, we need to find velocity because this is the coefficient of restitution equation. That is the speed after the collision divided by speed over the collision. And so we just plug it in like the previous one, and I should get this one, okay. And also I need to find the main point. Besides finding out the coefficient, I need to find out to see if the height decreases. If we decrease the height, the original height, will the final height, which is when it already bounced off, will be different or is the same. So in order to do that, the same thing, I just follow the same rule. I just write down before collision and after collision, before and after, and I just use the same equation. I just solve them. However, I just need to change the value right here. Instead of 150 meters that I got, now I just put number 100 meters there, and I got the velocity there. And also for after impact, I still write down the same equation, and I just put down the values I know, and the equation again was this one. Okay, don't forget this equation right there, it's very important. Okay, and so the same thing, I substitute 100. The difference between this one and the other one is that we don't know the final velocity, the initial velocity, which is the same with the other one, but now we don't know the height when it just bounced off. However, we know the coefficient of restitution, so we just solve like the previous one, but we just leave those variable there. We just put VA1, like that one over there, VA1, or we just leave like things like HA2, okay, and then we just plug in the number and we solve it. The plug-in number is just like that. This is the final velocity once it bounced off, when it reaches the height, the maximum height right there. this is initial height, this is final height once it bounced off. So the velocity right there is 0 because it does not move anymore. Okay, and that's my word right there. Remember, you need to divide into before and after collision, and because the value right here is smaller than the value that we took during the experiment for the final height, which was 61 meters. You see 61 meters. After collision, it'll bounce off and reach the maximum height, which is 61 meters right there. So you can see that the second one is smaller. Therefore, I came up with a conclusion that that if we decrease the initial position when I'm holding the ball, if I decrease that position or the height, then the final height or the final position would also be smaller than the first one. Not the initial one, but the first result. And that's pretty much it. I hope this helps. If you have questions, feel free to put comments there, and I'll try to answer your question as soon as possible. Or that's pretty much it. Or call me maybe at 911-611-7111. Okay, and I'll probably change my phone if it broke, but for now it's that number. Alright, thank you so much and have a good night, because right now it's night. Okay, thank you for watching. Bye.